Hi everyone. In this video, we will learn how to find arc length and area of sector for circle without remembering any formulae. So how to find the arc length in a circle? So here, let's define what is the arc length. Arc length is, in this particular example, this is the arc length. Now, how do you know this is the arc length? Well, arc length is the length of the arc in a circle formed by this central angle called theta. So we are given this angle called theta, which is the angle which is a central angle formed by two radii at the center of a circle, and the corresponding arc that is formed by this angle is called the arc length. So how do we find the length of it, right? Given the central angle. So we know that the circumference of a circle is 2 pi r. Now this is true when the central angle is 360 degree. So far so good. Now what we would like to see it is that what is the arc length? So let's call this arc length as x, right? So what is the arc length when the angle is theta at the center? Again, it's in degrees. Now, if we simplify this expression for x, then what do we get? We get theta degree divided by 360 degrees times 2 pi r, and that is our formula. So we don't have to remember this formula, we just have to remember how to reach to this formula and we can solve the problems. So let's take a specific case, right, wherein we have a radius equal to, say, let's say 10 centimeters, and the central angle is, say, 100 degrees, right? So in this case, again, we can use the same principle that we learned it, that I will have 2 pi r as the circumference when the central angle is 360 degree. So what will be my arc length, which is x, when the central angle is theta degree, right? And therefore we can just do the substitution at this point, that 360 degree divided by 100 degree here is equal to 2 pi times r is 10 centimeter divided by x. And when we solve for the x, we get the answer as 17.4 recurring centimeter. The units are singular here because the arc length, as we know about it, is measured in terms of a singular unit. It's the length, which is a singular unit. So we just keep that unit as a unit. In this particular case, it's a centimeter. Now let's jump to find the area of sector. So similar is the principle to find even the area of sector, right? So the total area of the circle, we know that it is found by pi r square, right? Now when the area is pi r square, the central angle formed is 360 degree. What we are interested in finding is this red shaded region, let's call it x. When that is the area, which is the sector area, at that point in time the central angle is theta degree. So what we have to solve in here is for the x, right? So if we just simplify this expression, then what do we get? We get theta degrees over 360 degrees times pi r square. And this is pretty much what we have as a formula to find the area of a sector. So again, let's take the same radius that we took it in the last example, that r is equal to 10 centimeter, and let's take a central angle equal to, in degrees, equal to, say, 100 degrees, right? And let's start finding the area of a sector. So in that case, again, let's follow the same process, that when the area is pi r square, my central angle is going to be 360 degrees. What I'm interested in is the area of this sector, which is a red shaded region. Let's call that x, when the central angle is going to be 100 degrees, right? And we just have to solve for x, which is equal to 100 divided by 360 times pi times radius, which is 10 square. And if we just solve that for x, then the value that we get, it is 87.2 recurring centimeter square. Remember, the centimeter square is because this is the area. They are essentially square units, and our unit in this particular case is centimeter, so therefore we chose centimeter square as the unit. So that's your area of a sector. Now, how are we able to apply area of sector and area of area of sector and the arc length? We are able to apply that the proportionality principle here, because as the central angle grows, so is the case with area, and as the central angle grows, so is the case with the arc length. So arc length is directly proportional to the central angle, as well as our area of sector is proportional to the central angle, and therefore we can apply the equality that we saw it here in the area of sector, or we saw it in the arc length case. And this concludes the video for finding the arc length and the area of sector in a circle. If you like this video, please subscribe to the channel to receive more updates on our future videos. And if you would like to know more about how to find the area of sector and the arc length given the central angle in radians, do let us know in the comment section, and I can record another video which explains how to go about finding these lengths and the sector area given the central angle in radians. I've chosen degrees as the measure here, just to simplify it. But again, instead of a degrees, if you'd like to see the video with the radians, please comment us and we will put another video for that. Thank you.